Greetings, welcome to this new video about Supermesh analysis. Solve the problem number 1. Let's consider this network consisting of 5 resistors labeled R1 through R5, as well as 1 voltage sources V1 and 2 current sources IA and IB. The question now is to calculate the power supplied by the voltage sources. Let's move on to the solution. First, let's begin by defining the number of meshes in this network. It's evident that there are 3 meshes. This is mesh 1, mesh number 2, and mesh number 3. Now, let's proceed to assign the mesh currents in this network. And I will consider I1 is the current in mesh 1, I2 is the current in mesh 2, and I3 is the current in mesh 3. We can see here that the mesh currents are chosen in the clockwise direction. After we finish the assignment of the mesh currents, we need to remove the 2 branches contains the current sources IA and the current sources IB. Then we obtain our supermesh. We currently have our supermesh. We need to apply Kirchhoff's voltage law in the supermesh. We can write R1 I1 plus R2 I2 plus R3 I2 plus R5 I3 plus V1 is equal to 0. By replacing the resistors and the voltage with their numerical values, we obtain 20 I1 plus 15 I2 plus 15 I3 plus 20 is equal to 0, and I will call this equation 1. We currently have an equation with the 3 unknowns, which means we require 2 additional equations to solve this problem. In order to get the 2 other equations, let's focus on the current source IA and the current source IB. Then we can write IA is equal to I1 minus I2. That means I1 minus I2 is equal to 5. Let's move on to the current source IB. We can see here that IB is equal to I3 minus I1. That means I3 minus I1 is equal to 3. Then we have 3 equations. We still only need to solve them to obtain our mesh currents. Let's start first by I2 is equal to I1 minus 5 is obtained from equation 2. And from equation 3 we can write I3 is equal to 3 plus I1, and I will call this equation B. By substituting A and B in 2, we obtain 20 I1 plus 15 I1 minus 5 plus 15 multiplying by 3 plus I1 plus 20. We derive 1 equations with 1 unknown. If we continue simplifying this equation, we obtain 50 I1 minus 10 is equal to 0. That means I1 is equal to 10 over 50 is equal to 0.2 amps. I3 is equal to 3 plus I1, that's from equation B. Then we obtain I3 is equal to 3.2 amps. We already found the mesh current I3, and we know the voltage across V1. That means we can calculate the power supplied by the voltage source. We know that the power supplied by the voltage source is equal to V1 multiplying by I3. That means the power is equal to V1 is 20 volt multiplying by 3.2 amps, we get 64 watt. After completing the calculation, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our circuits done by Spice simulator, we can see here this is our current source IA 5 amps, IB 3 amps, and we have our voltage sources V1 is 20 volt and resistor R1, R2, R3, and this is R4, and this is our resistor R5. In order to measure the power supplied by the voltage sources, we connect here a wattmeter and here like to measure the current I3. Let's go to analysis, DC analysis, calculate nodal voltage. We can see here that the power supplied by the voltage sources is 64 watt and the current I3 is equal to 3.2 amps. Those values are exactly the same value we have done by calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share, and see you next time in another example about Supermesh analysis. Have a nice time and bye bye.